All right, so on today's lesson, we are going to be taking a look at some of these graphs here. We want to go ahead and identify our A value. In this case, we're doing scaling and reflecting absolute value graphs. So in this case, guys, whenever we're finding our equation here, we're actually finding g of x equals A times the absolute value of x. Our focus in this case, guys, is only finding A. So let's go ahead and do that. In this case, guys, just a few things to talk about. Whenever we're talking about A in this case represents a slope, which slope in this case is rise over run. Another thing to talk about is that when something's being reflected, it's telling us that our A value is negative. Now, if something is being reflected, it's going to actually be an upside down V. Upside down V. And it comes in different shapes, guys, but in this case, it will be upside down. So if you see a graph in this case that is upside down, we know that our A in this case will be negative. So let's go ahead and start off here, guys, with the first one. In this case, guys, there's actually no easy way for us to actually work this out or work a way around it. The goal in this case is to actually find points in this case that make that cross exactly at an intersection. So what I mean by an intersection is that if I have this here, this is an intersection, I should have a point right at the center, crossing it. I should have a point here, point there, point here, point there, anywhere there's an intersection. A point won't be valid if it's somewhere here or there or there or there. Has to cross exactly at an intersection. So that's what we're looking for. So in this case, guys, starting off with the blue one, I do want to go ahead and just point out my points here or highlight them a bit. The slope for this one is 1 over 1. So if I go 1 up, 1 to the right, I will be finding points there. And I'll actually repeat it on the same side, on the left-hand side. So it's 1 up and 1 to the left. 1 up, 1 to the left, 1 up, 1 to the left, 1 up, 1 to the left, and so on. So we have that there. Now I'm going to go ahead and do the same thing here with the dashed one. And the goal in this case is to find points that are intersections. So these all are intersections. So let's go ahead and find it on this one. So if we take a look at this one there, it's not crossing exactly at an intersection. So if we go here, that one actually does work. Moving on to the other ones, that one doesn't. This one does. That one doesn't. This one does. And we just keep on going, right? Now, in this case, for those that do cross in this case, that's actually representing the slope. So I want to actually count from this point, which is our center, to this point here. So we're starting off, we want to see how much we're going up and down and how much we're going left and right. So in this case, we actually go up 1 and we run 2. So this is talking about slope, guys, talking about slope. Slope in this case is going to be equal to the rise over the run. And in this case, how much we're rising is 1, how much we're running is 2. So A in this case equals 1/2. So if I want to go ahead and write my equation here, I have g of x in this case equal to 1 over 2 and the absolute value of x. And that is our answer. That is our answer. All right. So once again, we're trying to take a look at where the points cross exactly at an intersection and from there determine the slope. So let's go ahead and move on to the next one, guys. Let's go ahead and move on to the next one, and here's the next one. And in this case, guys, once again, the one that's changing is the one that's dashed. So I want to go ahead and find the points there. So starting off, guys, we have one here that's not an intersection, another one there, not an intersection. This one's actually pretty close. But if we go on to the next one, we find an intersection there. If we just keep on going, we find another intersection down here. So let's go ahead and find the slope in this case, guys, from our center, which is 0, 0, here, to this point there. So we're starting from here to there. Now, in this case, guys, slope is rise over 1. We're actually going down 4, and we're running 1. So slope in this case is equal to the rise, which is -4, and the run, which is 1. Or this simplifies to a -4. So A in this case, guys, is a -4. Now, notice how our absolute value graph is downward. This is actually telling us that our slope should be negative, which indeed it is. So let's go ahead and write our equation here, guys. We have g of x equal to a times the absolute value of x. So g of x in this case equals -4 times absolute value of x. And that is our answer. All right, that's our answer. And if you guys just want to double check, guys, from this point to that point, it should be the same exact distance of the slope. So we're going to go, we're running 1, going down 4. 1, 2, 3, 4, and that's true. All right, so that's 1, and that's 4. Down. All right. And it should be the same thing on the opposite side, but in this case, guys, we're just focused on the right-hand side. And whatever we find on the right-hand side repeats on the left. All right, so that's that. And the last one, guys, I want you guys to do this one on your own and go ahead and find the points of intersection there.